Okay, so the first question is find the value of cot minus 135, cosec minus 1410, cos minus 870. Now cot minus 135. The first is cot minus 135 degree. We can take minus sign common, minus cot 135. Now cot 135 can be written as 90 plus 45. So we write this as minus cot 90 plus 45. Now see, this is 90 is basically what? Pi by 2. So cot will change to tan. And for 90 plus 45 will take you to the second quadrant. And in second quadrant, sine and cosec is positive. Cot is negative. So negative becomes positive. Cot becomes tan. So this is tan 45, which is equals 1. Okay. The next question is cosec minus 1410 degree. Now in this case, we are not changing it to the pi or the radian. Cosec, we can write minus cosec. Now 1410 degree, we can write this as 4 into 360 minus 30 degree, like in terms of 360. Now 360 degree is a complete rotation. Now complete rotation. Now 4 complete rotation, 1, 2, 3, 4, minus 30 will take you to the fourth quadrant. So this lies in the fourth quadrant. And in fourth quadrant, cosec is negative. So this is, and because this is, first of all, write cosec 30. And this will remain cosec only because this is 360. And even multiple of pi by 2, which is 360. So in case of 180 and 360, it will not change. Or simply in case of 180 and 360, it is not going to change. In case of 90 and 270, that will change. So cosec will remain cosec. Cosec 30 is equals, the answer is 2. Now third part. Cos minus 870. Again, now 1 point. Cos minus 870. Again, this is what, if you remember, cos of minus theta is cos theta. Okay, I think if you remember this, we have discussed, not in this, just a second, I'll show you. Yeah, cos of minus theta is cos theta. Okay, so cos of minus 870, we can write this as cos 870. Now cos 870, we can write cos this as 2 into 360 degree plus 150 degree. Okay, so again 360 plus 150, you can see twice rotation and 150 degree. So twice rotation, 2 into 360. This is a complete rotation. This is second complete rotation. 150 degrees in second quadrant. Second quadrant, cos is, I think, cos is, no, 360. 1, 2 and 150. Yeah, this is in second quadrant. Okay, so this is cos, second quadrant negative, cos 150 degree. Second quadrant. Okay, you can write this as cos 180 minus 30 degree. Again, this is in this is 180, so it will not change. And 180 minus 30, second quadrant. In this case, cos is negative, so this is cos 30 degree, which is equals to root 3 by 2. Okay, so now next example. Find the value of all trigonometric functions. Now the question is 150 degree. Okay, so we shall start with sine. Sine 150 degree. Actually, what is sine 150? Sine 150 degree is sine 180 minus 30 degree. You can write 150 as 180 minus 30. Now again, this is 180. This will not change. And 180 minus 30 is in second quadrant. Second quadrant, sine is positive. So this is equals to sine 30 degree, which is equals 1 by 2. Okay. Now cos 150 degree. We have to find cos 150 degree, that is equals to cos 180 minus 30 degree. Now you should know this. 150 can be written as 180 minus 30, which is in second quadrant, but in second quadrant cos is negative, and this is 180, so it will remain cos. So this is equals to cos 30 degree, but that is negative, minus cos 30 degree, which is minus root 3 by 2. Okay. Tan 150 degree. Now tan 150 degree is actually, you can write sine 150 by cos 150 by cos 150 degree. Okay. Now sine 150 degree is 1 by 2. This is minus root 3 by 2. You solve it, you get minus 1 by root 3. This is tan 150 degree. Cot 150 degree. Cot 150 is the inverse of tan 150, which is minus root 3. Inverse of this. Sec 150. Sec 150 is basically inverse of cos 150. Cos 150, which is minus root 3 by 2. So this will be 2 by minus 2 by root 3. And cosec 150 is the inverse of sine 150. This is 1 by 2. Sine 150 is 1 by 2. To cosec 150 will be 2. So cosec 150, this will be 2. So these are the values of all trigonometric functions of 150 degree. Now take one more example. Show that sine 105 plus cos 105 is 1 by root 2. Okay. Now starting with, now you know that this is LHS, this is RHS. Starting with the LHS, we can write 105. Now see, 105 is 60 plus 45. So this is sine 60 plus 45 plus cos 60 plus 45. Now applying the formula of sine A plus B and cos A plus B. Now this is sine A plus B is sine 60 cos 45 plus cos 60 sine 45. Okay. Plus this is cos 60 cos 45 minus sine 60 sine 45. Now just putting down the values. Now sine 60 is what? Sine 60 is root 3 by 2 into cos 45 1 by root 2 plus what is cos 60 is 1 by 2 sine 45 1 by root 2 plus cos 60 is 1 by 2 cos 45 1 by root 2 minus sine 60 root 3 by 2 sine 45 1 by root 2. Okay. Now solving this. This is what? Root 3 by 2 root 2 plus this is 1 upon 2 root 2 plus this is 1 upon 2 root 2 minus this is root 3 by 2 root 2. These two will get cancelled. Added up, this will be 2 upon 2 root 2. You cancel, which is 1 upon root 2. Hence proof. 1 upon root 2. This is proved. Okay. Now we have, let's go to our next example. Cos 15 degree, sine 75, tan 75, tan 13 pi by 2. So let's start with cos 15 degree. Now see, cos 15 degree, you can write cos 15 as 45 minus 30. So this is basically cos 45 minus 30. Now use the formula cos A minus B. Cos A cos B minus sin A sin B. So this is cos A cos B minus sine A sine B. Cos 45 degree is 1 by root 2. Cos 30 is root 3 by 2 minus sine 45 is 1 by root 2. Sine 30 is 1 by 2. So this is root 3 by 2 root 2 upon this is root 3 by 2 root 2 minus 1 upon 2 root 2. So basically root 3 minus 1 by 2 root 2. This is cos 15 degree. Now sine 75 degree. Our next question is sine 75 degree. Sine, no, 75, you can write 75 as 45 plus 30. So write sine 45 plus 30. Okay. Now sine A plus B is sine A cos B plus cos A sine B. So this is sine 75 is sine 45 cos 30 plus cos 45 sine 30. Okay. What is sine 45? Sine 45 is 1 by root 2. Cos 30 is root 3. Cos 30 is root 3 by 2 plus cos 45 degree again 1 by root 2. Sine 30 1 by 2. Okay, so this is actually root 3 by 2 root 2 plus 1 by 2 root 2. So you know the LCM is 2 root 2 only, and this will be root 3 plus 1 by 2 root 2. Okay. Now we have tan 75. Again 75, sorry, let's write the question first. Tan 75. We know that tan 75 is 45 plus 30. So this is tan 45 plus 30. Now use the formula tan A plus tan B upon 1 minus tan A tan B. So this is tan 45 plus tan 30 upon 1 minus tan 45 tan 30. Tan 45 is what? 1. Tan 30 is 1 by root 3 upon 1 minus tan 45 and tan 33 is 1 by root 3 only. Because this is tan 45 is 1, tan 30 is 1 by root 3, that is 1 by root 3. Now solve this. Solving this, we get root 3 plus 1 upon root 3 minus 1. Okay. Now our next example is tan 13 pi by 12. See, basically 13 pi by 12, you can write this as tan as pi plus pi by 12. Now see, again this is pi, so at pi this will not change, and tan pi plus pi by 12, that will be in the third quadrant. Tan is positive, so this will be tan pi by 12. Tan pi by 12. Now tan pi by 12, you can write tan pi by 12 as tan pi by 3 minus pi by 4. Tan pi by 3 minus tan pi by 4. Now applying the formula, tan A minus B is tan A minus tan B upon 1 plus tan A tan B. So this is tan A minus tan B upon 1 plus tan A tan B. This is equals to tan pi by 3 is what? Root 3 minus 1 upon this is 1 plus tan pi by 3 is root 3. Tan ka 1 plus root 3. Okay. So you know that rationalizing, this is root 3 minus 1, this is root 3 plus 1 into root 3 minus 1 upon root 3 minus 1. Because 1 plus root 3 can be written as root 3 plus 1. Now negative of that. So this is root 3 minus 1 whole square And this is a plus b into a minus b. A square minus b square. 3 minus 1, 2. Okay, so the above will be, this is a square plus b square minus twice of ab upon 2. So this is what? 4 minus 2 root 3 by 2. Take 2 common. 2. This will be 2 minus root 3 by 2. 2 cancel. So the answer is 2 minus root 3. That is the answer. Some more examples. Prove that sine 70 cos 10 minus cos 70 sine 10 is root 3 by 2. So basically in this example, we have to recognize like what formula is being used. Now see, considering this as A, this as B. So this is sine A cos B minus cos A sine B. So this is basically the formula that they have used is cos A minus B. Sorry, sine A minus B. I'm sorry for that. So for first one is sine A minus B is sine 70 minus 10, which is what? Sine 60 degree. And what is sine 60 degree? Is root 3 by 2. So we have proved this in the first step only. Now second one. Again the same thing. Cos 80 cos 20 plus sine 80 sine 20 is 1 by 2. Now what's formula is this? Cos A cos B sine A sine B. So it's cos A minus B. So we can simply write cos 80 minus 20, which is cos 60, and cos 60 is what? 1 by 2. Proved. Third one. Now if you see, look closely at third one, is sine 40 plus theta, cos 10 plus theta minus cos 40 plus theta, sine 10 plus theta is 1 by 2. Now look carefully. If we take this as A, this as B. So what is this? Sine A cos B minus cos A sine B. So this is again the formula of sine A minus B. Now what is A over here? A is 40 plus theta and B is 10 plus theta. Okay, so we just write sine in bracket 40 plus theta minus 10 plus theta. Solve it. So this is sine 40 plus theta minus 10 minus theta. Minus theta cancel. Sine 40 minus theta is sine 40 minus 10 is sine 30 degree. So this sine 30 degree is what? Is 1 by 2. Hence we have proved. Okay. Now the fourth part. Sine pi by 4 cos pi by 4 plus cos pi by 4 sine pi by 12. Sorry, this was pi by 12. So this is sine A cos B plus cos A sine B. Formula is sine A plus B. That means sine pi by 4 plus pi by 12. So this is fourth one is sine pi by 4 plus pi by 12. Oh, sorry. Pi by 4 plus pi by 12. Now, if you solve this, sine pi by 4 plus pi by 12, you will get sine pi by 3. Now, what is sine pi by 3? Is 180 by 3, which is 60 degree. So, sine 60 degree is root 3 by 2. Root 3 by 2. So, as you can see in these formulas, we just have to recognize which of the formulas is being used up. Okay. Moving on to our next example. Now see. What they have given is cos 90 plus theta, sec 270 plus theta, sine 180 plus theta, upon cosec of minus theta, cos 270 minus theta, tan 180 plus theta, that is equals to cos theta. So see, directly what we can write is that, see, what is cos 90 plus theta? See, this is 90, the cos will change to sine. Now it is in which quadrant? 90 plus theta will be in second quadrant. The cos is negative. So this will be minus sine theta. Okay. Sec 270 plus theta. Again this is 270. So in 270 sec will change to cosec. But 270 plus theta will be in fourth quadrant. This is 270 plus theta in fourth quadrant. In fourth quadrant, cos and sec is positive. So sec is positive. But sec will change to cosec. This will be cosec theta. Okay. Sine 180 plus theta. Now this is 180, sine will remain sine. But 180 plus theta will be in third quadrant. Negative. So minus sine theta upon cosec of minus theta. See, again we have discussed this before also. Like cosec of minus theta is what? Cosec of minus theta is minus cosec theta. Okay. So cosec of minus theta, this will be minus cosec theta. Cos 270 minus theta. Now this is 270. The cos will change to sine. But 270 minus theta is in third quadrant. 270 minus theta. This is 270 minus theta is in third quadrant. So what will happen? Cos will change to sine. Negative sine. Minus sine theta. Tan 180 plus theta. 180 plus theta is in third quadrant. This is 180. So tan will remain tan theta. Okay. Now minus sine theta cancel. This minus cancel. Cosec theta cancel. So this is basically sine theta. Inverse of tan theta is cot theta. So this is sine theta. Cot theta is cos theta by sine theta. Sine theta get cancelled. You get cos theta. Okay. Now, next example. Cos 3 pi by 2 plus theta. Now cos 3 pi by 2 plus theta, this is 3 pi by 2, so this will change. 3 pi by 2 plus theta will be in the fourth quadrant. Cos is positive. So cos will become sine. This will be sine theta. Cos 2 pi plus theta. 2 pi, the cos will not change. This is in the first quadrant. The cos theta will remain cos theta with positive sign. Cos theta. Bracket. Cot 3 pi by 2 minus theta. 3 pi by 2 minus theta is in third quadrant. 3 pi by 2, so this will change to tan. And tan is positive. So this is tan theta. Plus cot 2 pi plus theta. 2 pi plus theta is in first quadrant. 2 pi, cot will not change. So cot theta. Now solve this. This is sine theta, cos theta. Tan theta is basically sine theta by cos theta, plus this is cos theta by sine theta. Okay. So when you solve this, LCM is cos theta sine theta, and this will be sine square theta plus cos square theta. So write like this: sine theta cos theta. This will be sine square theta plus cos square theta upon sine theta cos theta. Sine theta cos square theta is 1. This and this will get cancelled. So answer is 1. Hence proved. So next example. Cos A is 4 by 5. Cos B is 12 by 13. Now see, where A and B both lies in the fourth quadrant. This is an important point. Now find the value of cos A plus B, sin A minus B, tan A plus B. That is a different thing. First of all, now see. Now we know that A lies in fourth quadrant. So that means cos A will be positive. But you know, sin A negative, tan A negative. Okay. B lies in fourth quadrant. Cos B is positive, sin B negative, tan B negative. So these points you should consider. Now we have cos A. Cos A is 4 by 5. We have cos A is 4 by 5. So we can find sin A. Sin A is how much? Sin A will be under root of, but sin will be negative, minus under root of 1 minus cos square A. Cos square A, which is minus under root of 1 minus 16 by 25 which is equal to negative of 9 by 16, sorry 9 by 25, so which is equals to sine A is minus 3 by 5. Now we can find tan A. Tan A will be sine A by cos A, which is minus 3 by 5 whole upon cos A is given to be 4 by 5. 4 by 5. So this is basically minus 3 by 4. So now we have the value of tan A. We have the value of cos A, sine A, tan A. Now cos B is given to us. We can find sine B. Now sine B is what? Sine B is actually negative. Sine B is minus under root of 1 minus cos square B, which is minus under root of 1 minus cos square B will be 144 by 169. 144 by 169, which is equals to minus under root of 25 by 169, that is equals to minus of 5 by 13. Now we can find tan B because we have sine B and cos B. Tan B is sine B by cos B. Sine B is minus 5 by 13. Cos B is 12 by 13. So which is minus 5 by 12. So we have all the values. Okay. So as you can see, we have all the values. Sine A minus 3 by 5. Tan A minus 3 by 4. Sine B minus 5 by 13. Tan B minus 5 by 12. Okay. Now the first part is cos A plus B. Now the first part is cos A plus B. Okay, so let's solve it over here. Cos A plus B. Now use the formula. This is cos A, cos B minus sine A, sine B. Okay, now what is cos A? Cos A is in the question 4 by 5, cos B 12 by 13. So cos A 4 by 5 into 12 by 13 minus sine A, sine B. Sine A is minus 3 by 5. Sine A is minus 3 by 5. Sine B minus 5 by 13. Sine A. Now sine A, sine B. Sine A is minus 3 by 5. Sine B is minus 5 by 13. Okay. So this is minus 3 by 5 into minus 5 by 13. Okay. So this is 12 4s are 48, 13 5s are 65, minus this is 5 3s are 15 by 65, which is 33 by 65. Second part is sine A minus B. Sine A minus B. Applying the formula. Sine A cos B minus cos A sine B. Sine A cos B. What is sine A? Sine A is minus 3 by 5. Cos B is 12 by 13. Sine A minus 3 by 5 and this is 12 by 13 minus cos A sine B. What is cos A? Cos A is 4 by 5. Sine B is minus 5 by 13. Okay. Now solving this, you get this as minus 36 by 65 plus 20 by 65. this is what? Minus 16 by 65. That's the answer. Next is tan A plus B. Tan A plus B. Applying the formula. Tan A plus B is tan A plus tan B upon 1 minus tan A tan B. Substituting the value. Tan A. What is tan A? Tan A is minus 3 by 4. Tan B is minus 5 by 12. Okay. Minus 3 by 4 plus minus 5 by 12. 1 minus tan A is minus 3 by 4 into minus 5 by 12. Okay. So when you solve this, taking 12 as the LCM, you will get minus 7 by 6. Okay. And this is actually 1. This will become positive. So minus, this goes 4 times. 3 1s are 3, 3 4s are 12. So this is 5 by 16. 5 by 16. So this is basically minus 7 by 6 into 16 by 11, which is minus 56 by 33. That's the answer. Next question is tan 70. You have to prove that tan 70 equals tan 20 plus 2 tan 50. Now starting with the LHS, tan 70. Like tan 70 can be written as tan 20 plus tan 20, just cut it, this is 50. Tan 70, that tan 20 plus 50. Now apply the formula of tan A plus B, which is equals to tan A plus tan B upon 1 minus tan A tan B. Now cross multiply. Cross multiply, this will be tan 70 minus tan 70 tan 20 tan 50 equals tan 20 plus tan 50. Now tan 70, you can write tan 70 as 90 minus 20. Yeah. So tan 70, this will be tan 90 minus 20 into tan 20 tan 50 equals tan 20 plus tan 50. Now this tan 90 minus 20, 90 minus 20 is in first quadrant. This is 90, the tan will change to cot. This will be cot 20. So writing again the whole thing, tan 70 minus this is cot 20, tan 20, tan 50 equals tan 20 plus tan 50. Cot 20, tan 20 will get cancelled. So this is tan 70 minus tan 50 equals tan 20 plus tan 50. Now you take this minus tan 50 to that side, this will become plus. So this will be tan 70 equals tan 20 plus this will become 2 times. So this will 2 tan 50, which is proved. Now, next example. Cot 2x, cot x minus cot 3x, cot 2x minus cot 3x, cot x equals to 1. As you see, there are many things. But simply what we can do is that we know that cot 3x can be written as cot 2x plus x. Now apply the formula of cot A plus B. So this is cot A, cot B, cot 2x into cot x minus 1 upon cot x plus cot 2x, cot B plus cot A. Just cross multiply. So when you cross multiply, this will be cot 3x cot x, this is cot, plus cot 3x cot 2x equals cot 2x cot x minus 1. Okay. Now just rearranging them. Now when you rearrange them, like means to take one to that side and these two to this side. This will give you like cot 2x into cot x minus cot 3x cot 2x minus cot 3x cot x equals 1. We just have to rearrange it. That is all.